Hello everyone, I am Tushar Koli, Assistant Professor and Head of Mechanical Department at Godavari College of Engineering, Jalgaon. I heartily welcome you all on this lecture series, which is based on mechanisms and motion, which relates to theory of motion. So, we will start the session with first lecture which is on fundamentals and types of mechanism. So, in this fundamental section, we will study what is meant by theory of motion and different branches, or you may say subdivisions of theory of motion. So, very first, we will see details of theory of motion. So, as you can see here, animation of IC engine, where number of parts are in relative motion and similarly various forces are acting on that. So simply we can say that theory of machine is defined as that branch of engineering science which deals with the study of relative motion of parts and forces which acts on them. Next, here in this you can see that there are four subdivisions of theory of motion as follows. In all these branches, we clearly study theory of motion in various aspects like relative motion, forces, inertia, effect of forces, and all that. So one by one we will see it. Okay. In this you can see that kinematics, dynamics, kinetics, and statics. So in kinematics, we will study related to the relative motion between the various parts of motion. In dynamics, we'll study the forces and their effects while acting upon the machine parts in motion. Third subdivision is kinetics. It is the branch of theory of motion which deals with the inertia forces which arise from the combined effect of the mass and motion of the machine parts. And last is statics. It is that branch of theory of machine which deals with the forces and their effects when the machine parts are at rest condition. Here the mass of the parts is assumed very negligible. Okay, so all these are the subdivisions of theory of machines, that is kinematics, dynamics, kinetics, and statics. Moving further, again we are having a particular slide. In this, theory of machine is having two sub branches, main sub branches, that is dynamics and statics. Dynamics is having again two sub categories, that is kinetics and kinematics. Okay, so all these are the four sub branches of theory of machine. Moving next, now here you can see that moving further For the mechanism topic, we all have to understand some important related terms. One of the term is kinematic link, or you may say that element. So definition for that kinematic link is each part of a machine which moves relative to some other part is known as a kinematic link, or simply link, or you can say element. Now in this we will see the different types of the links with the help of some animations also. So as you can see here, the animation of a particular assembly, that is, in that you can say rigid link is one which does not undergo any deformation while transmitting the motion. Simply we can say that such type of link do not exist in the universe, because there will be always deformation while using the number of elements. So different rigid links can be considered as connecting rod, crank, etc. These can be considered as rigid link. Moving further, flexible link. So as you can see the animation of a chain drive, or you can see the animation of belt drive. Here a flexible link is one which is partly deformed in a manner not to affect the transmission of motion. And the examples are belts, ropes, chains, and the wires are flexible links and transmit tensile forces only. Moving next, we are having fluid link. Here you can see that the animation for fluid link. A fluid link is one which is formed by having a fluid in a receptacle, and the motion is transmitted through the fluid by pressure, or you may say by compression, as in the case of hydraulic presses, jacks, and brakes. These are the examples for fluid links. Moving further, in this slide you can see the structures. For example, bridge is here, and a machine framework is here. So with these figures you can say that it is an assemblage of a number of resistant bodies which is having no relative motion between them and meant for carrying loads having straining action. For example, railway bridge can be considered as structure, a roof truss, machine frame. These are the examples for the structure. Moving next. Now here in the slide you can see the clear difference between machine and structure. So in machine there are different parts and they move relative to one another. While in structure, the members, there are members of a structure, but they don't have relative motion between each other. Second difference, we can say that a machine transforms the available energy into some useful work. In structure, no energy is transformed into useful work. Third, we can say that the links of a machine may transmit both power and motion, but in structure, only forces can be transmitted. For example, we can say that drilling machine, lathe machines, these are the examples for machine. Then machine frames and bridges, these are the example for structure. Now, next we'll discuss about the kinematic pair. Okay. In this figure, as you can see that we are having two kinematic links. When they are in contact with each other, they are said that they are forming a pair. But when a particular relative motion takes place between them, maybe completely or successfully, then that pair is known as kinematic pair. Now, considering this, we are having different types of constrained motion. First one is completely constrained, second is incompletely constrained, third one is successfully constrained motion. Now, one by one, we will discuss about them. So first one is completely constrained motion. In this figure, you can see that we are having a square hole and square bar. They are having a particular relative motion between them. Means when the motion between a pair is limited to a definite direction, irrespective of the direction of force applied, you can say that square bar reciprocates through the square hole. Okay. Similarly, for example, we can say that piston and cylinder assembly. Again, here piston reciprocates with respect to cylinder. Means in a definite limited direction. So then we can say that it is completely constrained motion. Next is incompletely constrained motion. Now in this figure you can see that a round hole and a shaft, they are having relative motion between each other. The shaft may rotate as well as may reciprocate through the round hole. Means more than one motion is there. So we can say that when the motion between a pair can take place in more than one direction, then the motion is called as incompletely constrained motion. For example, a circular bar or a shaft in a circular hole is an example of an incompletely constrained motion. Means that shaft is rotate or it may slide in a hole. Then next is successfully constrained motion. In this figure, you can say you can see that a footstep bearing. Okay, a shaft is there which moves or reciprocates or moves in upward and downward direction in that particular bearing, as well as that shaft rotates. Okay, so in this we can say that when the motion between the elements forming a pair is such that the constant motion is not completed by itself. You can see that two motions are there, in two directions motions are there. One is moving in upward and downward direction as well as rotation. So this will be incompletely constant motion. But when we put a particular load on that shaft, it will restrict one of the direction or moving in upward and downward direction, it will restrict. So the shaft will only rotate in that particular bearing. Okay. So with this we can say that the constant motion is not completed by itself but by some other means. then the motion is said to be successfully constrained motion. So considering the shaft, already we have discussed about it. Then moving next, classification of kinematic pairs. Now here we are having three different classifications, major classification for kinematic pairs. The first one is according to the relative motion between the elements, as you can see here. Second one is according to the type of contact. And third one is according to the type of closure. So one by one we will see. The first one is according to the type of relative motion. So regarding this relative motion, again we are having different classification for pairs or kinematic pairs. First one is sliding pair. So considering this animation for this pair, you can see the motion here. Similarly here also you can see the motion. Now when the two elements of a pair are connected in such a way that one can only slide relative to the other. In the figure you can see that one slide relative to the other. This pair is known as sliding pair. For example, the piston and cylinder, cross head and guides of a reciprocating steam engine. In shaper machine, you can see ram and its guide, then tailstock on the lathe bed. All these are the examples for sliding pair. Moving next, turning pair. As you can see here, the animation of a particular wheel, then the animation of the crankshaft. Here, when the two elements of a pair are connected in such a way that one can only turn, as you can see in the figure, one can only turn or revolve about a fixed axis of the other link. The pair is known as turning pair. For example, the crankshaft in a journal bearing, then lathe spindle, cycle wheels. These are the examples of turning pair. One focus point is that a turning pair also has a completely constrained motion, means a definite direction motion. Moving next, rolling pair. As you can see here, the animation of rolling pair, that when the two elements of a pair are connected in such a way that one rolls over another fixed link. This pair is known as rolling pair, and best example for rolling pair is ball and roller bearing. Moving next, screw pair. So as the name implies, in the figure and in the animation you can see the screw pair. Here you can say that when the two elements of a pair are connected in such a way that one element can turn about the other with the help of what? Screw threads. Hence the pair is known as screw pair. For example, you may say that the lead screw of a lathe with nut, then nut and bolt assembly. These are the examples for screw pair. Moving next, spherical pair. In the animation, you can see the motion. Here you can say that when the two elements of a pair are connected in such a way that one element which is having spherical shape turns or swivel about the other fixed element, the pair is formed and is called as a spherical pair. For example, ball and socket joint, attachment of a car mirror, then pen stand, These are the examples for spherical pair. Moving next. Now, this is the second major classification for the kinematic pair. And second is what? According to the type of contact between the elements. Okay. Previous we have seen according to the relative motion. Second one is according to the type of contact. So what type of contact is there? On that basis, we are having the classification for kinematic pair. So first one is lower pair and second one is higher pair. So first we will see lower pair. Already we have discussed about all these animations. So when the two elements of a pair have a surface contact, when relative motion takes place and the surface of one element slides over the surface of the other, is known as lower pair. Means focus point is that when the two pairs or the two elements of a pair have a surface contact. When surface contact is there, that pair is known as lower pair. Here you can see that surface contact is here. This is the surface contact of piston with the cylinder. Likewise. The next is higher pair. Now here you can say that when the two elements of a pair have a line or point contact, when relative motion takes place and the motion between the two elements is partly turning and partly sliding, then the pair is known as higher pair. As you can see here, cam and follower, here is line or point contact you may say. So when such type of contact is there, then the pair is known as higher pair. Moving next, third major classification for kinematic pair is according to the type of closure. What type of closure is there? On that basis, kinematic pairs also get classified. First one is self-closed pair. Here you can say that when the two elements of a pair are connected together mechanically in such a way that only required kind of relative motion occurs. Means when these two elements connected mechanically, that pair is known as self-closed pair. So for example, you may say that the lower pairs, all the lower pairs are the self-closed pair because they are connected mechanically. Next is force closed pair. Here the elements of a pair are not connected mechanically but are kept in contact by the action of external forces. These are called as force closed pair, and the major example for that force closed pair is cam and follower, as already we have discussed that there is a point contact and contact. Okay, so force closed pair, the major example is cam and follower. So these are the classifications according to the type of closure. Dear friends, so as in this session we have covered details related to fundamentals like branches or subdivisions of the theory of machine, the links and the types, pairs and the types, different constraint motion and all that. In the next session we will cover kinematic chain and different types of the joints. So till then, thank you very much. Thanks.